Chapter 11, Section 3. This is the last section. We're going to talk about acceleration. So what is acceleration? It's defined as being a change in speed, direction, or both. It can also be defined as a rate of change in speed or direction, or a rate of change in velocity. So because it has a direction, acceleration is a vector. And the units that we're going to use for acceleration for this class are meters per second squared. So that square only goes with the seconds, and it does not make the number squared, just the units is what has that square with it. So the first thing, changes in speed. It can be accelerating or decelerating. So you can increase your speed to accelerate, or you can decrease your speed to decelerate. So for example, if we are in free fall, that's taking any object and dropping it, the only thing affecting it is the Earth's gravitational pull. Now because the Earth does have a gravitational pull, that has an acceleration. And the acceleration due to gravity, and this is on Earth only, is 9.8 meters per second squared. So you can see here, we're not squaring the number. That's just what goes with our units. The other way that we can have changes, or we can have acceleration, is by a change in direction. So going around a curve or in a circle, majority of the time your speed is staying constant, but your direction is constantly changing. So think about a merry-go-round. And then of course we can have changes in both speed and direction simultaneously. And in those cases, think of a roller coaster. Now, there is a way for us to calculate acceleration, so this will be our second formula for the semester. And we are going to write this as the change in velocity over time. So this is a ratio. So acceleration should equal the change in velocity over the time. So when I say change in velocity, that means you need to have a starting velocity and a final or ending velocity. So we're going to write it as A equals VF, final velocity, minus VI, initial velocity, divided by time. Now here's the important part. If you are going to plug this straight into your calculator, make sure you plug your velocities in parentheses, because we want to make sure that it does this subtraction first before you divide. So here's your first example, and then you'll have some practice problems. We have a ball that's rolling down a ramp. It starts from rest, and after 2 seconds, its velocity is 6 meters per second. I want to know what is the acceleration of the ball. So here's your formula, change in velocity divided by time. So we have 2 seconds. We can clearly see that. We also have a velocity is 6 meters per second. So after 2 seconds, we have a velocity of 6 meters per second. But what was our initial or starting velocity? Well, if we look up one sentence, it says starting from rest. Now, I won't always give you numbers. I may say that it starts at rest or that it comes to a stop. Those are keywords that are going to indicate to you that your velocity, or whatever you're looking at, is initially or final 0. So if we plug this in, our change in velocity, remember, is VF minus VI. So we ended with 6 meters per second. We started with 0 meters per second, and our time was 2 seconds. So this is how you should have it written out. And you don't even need your calculator for this one. This one's a simple one. So 6 minus 0, well, that's just 6. 6 divided by 2, you should get 3. And then, of course, we need to add back in our units, which is meters per second squared. Now let's go ahead and walk through a practice problem. We have a car traveling at 10 meters per second. It starts to decelerate steadily. It comes to a stop in 20 seconds. What is its deceleration? Now, because we are decelerating, acceleration is going to be negative. So we're starting at 10 and we're going to 0. So when you write this out, you're going to have 0 minus 10 in the numerator, and then you're going to divide by 20. So what is negative 10 divided by 20? You should get negative 1/2, or negative 0.5. And that's meters per second squared. So now that we've looked at an example problem and I've walked you through one practice problem, an airplane travels down a runway for 4.0 seconds with an acceleration of 9 meters per second squared. What is the change in velocity during this time? So in this case, I'm asking you to go ahead and work backwards. So I gave you this time and I've given you the acceleration. I want to know, what is that whole top piece? All right, so go ahead and just like we manipulated the speed formula in the last section, go ahead and manipulate the acceleration formula so that you can find the change in velocity. Now moving on, there's one more thing I want to cover, and then we'll hit some highlights during class. Some graphs of accelerated motion. We are moving on to what's considered to be a velocity time graph. So we have velocity on our y-axis, our vertical, and we have time on the x-axis, our horizontal. Now remember, I said time is always independent. It will always be on the x-axis. So when you actually plot out some points and you have a line graph that's for velocity time, the slope of that line, your rise over your run, is the acceleration. And we'll look at some examples in class. But that's it for today.